Okay, so we're doing a little bit of review of classic right triangle trig. And tonight's new stuff is going to be about bearings versus true, and also about angle of elevation versus angle of depression. So first off, if I asked you to find y here, I hope you'd know how to set up an equation. I personally like this method of, you don't have to do this every time, of course, but if you kind of get stumped on which function to use, so toa, ka, apparently. So ka, toa. Which one of these don't I have? I don't have the adjacent side, so therefore I can't use these twos. Therefore, I should probably use sine. Sine of 28 equals 3 over y. Raise your hand if you had that. Okay, good. So to solve it, I just need to know what sine of 28 is. You use your calculator, it gives you a decimal. Let's say it came out to like 0.37 or whatever. Actually, this is a good time to get your calculator. Grab your graphing calculators and figure out what exactly, no, not exactly, what decimal estimate would you give then for y? Notice I changed from saying exactly. Exactly, as soon as you use a decimal, you have to round it. And therefore, it's not exact anymore. We'll do an exact one in a moment. That means you won't be using the calculator in a minute. So yeah, there's sometimes when, even though you'll have a calculator on the test, you can't use it because the teacher says in the directions, give an exact answer. And whenever you're using a calculator, you're rounding decimals. It's not exact. Actually, there's a few exceptions because some of these come out like sine of 30 comes out to 0.5. That is not an estimate. It's 0.5. You didn't round it. You know what I mean? So in theory, there's a few you could do with a calculator and still be exact. But all right, what was sine of 28? Just give me your first couple of places. What? 469. Okay. And then I'm going to multiply both sides by y. Why am I doing that? To get the y alone. Now I got to divide both sides by 0.469. What does 3 divided by 0.469 come out to be? 6.39? Would you agree about 6.4-ish? Raise your hand if you had that. Okay, good. Any questions about that kind? Okay, now let's talk about, what's this whole exact thing you're talking about, Mr. Server? Let's say that I said this was 2 and I said this was 30 degrees. I know it's easy. We just did it a second ago. To do this with a calculator, but let's say I wanted to know what y is exactly. Then you couldn't use the calc. You could, however, actually, no, I did a bad one here because you actually could use the calculator. I'm going to change this. I'm going to change this to, I'll put x down here. Now, with a calculator, the only thing you'd be able to get is an estimate because it's one of those decimals that goes on forever. But you could do it using your helper triangle. The 30, 60, 90 combo, 1, 2, square root of 3. If hopefully you know how to do this, because when you get quizzed on this, it'll say, give an exact answer. And some kids are going to just think, oh, calculators are exact. I'll just do that. Wrong. I'm going to pause for a second. Let me try that one. Okay. So what you should have done is, I personally like to set up a proportion. I think this is the easy way to do it. 2 is to x as 1 is to root 3. And then cross multiply. 2 root 3 is equal to x. Raise your hand if you had that one right. Okay, good. That's an exact answer because if you'd used the square root of 3 on your calculator, it would be this long decimal. You'd have to round it. Okay. So, last but not least, you did some really heavy-duty problems where you had nested triangles, one inside the other. I'm going to make these 2 different colors. This one's going to be significantly easier because I don't want it to take forever. Because I'm going to make this a 45, 45, 90 triangle on the red one. And this one's still your classic 30, 60, 90 triangle, the blue one. And my question is, let's just all agree to call this x and this y, and I want to know if I tell you one more thing, but I'm not going to be nice and give you this long side here, but if I tell you this side here is 8, would you please figure out for me exactly how long is x, which happens to be the same as y? I'll pause for a second and give that a try. This is where it gets to be more pre-calc level. Okay, let's see if you made some good leaps here. First thought, you can use sine, cosine, or tangent, but do you notice that this is a 45, 45, 90, and therefore those have to be the same? And if I'm trying to write equations, wouldn't it be a true statement that y equals x or that x equals y? Let's save some time. Otherwise, you could say sine of 45 is equal to, well, that's going to give me the hypotenuse, so I really don't want that. Tangent of 45, that's a good one. Tangent of 45 would be y over x. But tangent of 45, when you use your calculator, turns out to be equal to 1. Or, if you just want to look at your 45, 45, 90 triangle, what is the tangent of 45? That's a 45, right? Tangent is opposite over adjacent, so it's 1. So that's just 1 equals y over x. Multiply both sides by x. X equals y. However you get it, x equals y is a big deal. Why is that a big deal? Because in the other equation, which I personally, since we don't have hypotenuse and we don't even care about hypotenuse, I would have gone with tangent. Tangent of 30 is equal to y over 8 plus x. Notice this whole side needs to go together. Y over 8 plus x, or x plus 8. And then, since y equals x, we know y equals x, we could put in either there we could put a y, or there we could put an x. Doesn't matter. Solve for either one, because they're the same, right? Okay. But what's tangent of 30? Well, I can make my classic 30, 60, 90 triangle. 1, 2, square root of 3. What is the tangent of 30? Tangent is opposite over adjacent. 1 over root 3 is equal to, I'm going to change y to x over 8 plus x. And there we go. If I solve that, I'll have my answer. X, sorry, not 8. 8 plus x. There we go. Okay, and then I'm going to multiply, cross multiply that way, and I'll get x root 3 equals 8 plus x. Then I'm going to subtract x's from both sides, and I'll have x root 3 minus x is equal to 8. And this actually does involve a little bit of my favorite saying. You get other x's in both of those? If you can factor it, you should. To get this x alone, I'm going to factor an x out, and I have root 3 minus 1 equals 8. Once I figure out what root 3 minus 1 is, I could use a calculator and get a decimal for it, or I could just divide both sides by root 3 minus 1. So my final answer then would be x equals, getting rid of this classic triangle that I don't really need anymore. Divide by root 3 minus 1, divide by root 3 minus 1. X is equal to 8 over root 3 minus 1. Do you get if I said I want an exact answer, you'd need to leave it like that? Okay, well, that was pretty intense, I know. The test on that isn't going to be until about a week from now. So you got plenty of time to get smarter, get better at this. But your basics of trig that we boil down to, like, oh, I got to be able to write this equation. Being able to write those equations, that stuff you should have by today. And again, when I give you this quiz, the average score on it is 9.5 out of 10 on the other 2 hours. Okay, so you're going to do fine. It's not scary. But this is kind of where we're going, is intense problems like that. All right, so what's new for today? Let me talk over the new stuff for you, with you. I'm going to actually fast forward through a bunch of this stuff. Oh, wait a minute. That's a good one. Okay, bearings versus true bearings. Have you heard, oh, I need to get my bearings. That means, like, figure out, like, where I am. Like, if you're in a mall, I don't know if you've ever been in a mall and you're like, dang it, I don't remember where I parked at all. I got to kind of get my bearings. Like, was I over there or there or, okay, or even in the school sometimes when you're new to this school, you might have been like, I don't even know where the west lot is. I can't even point the right direction. Okay, well, getting your bearings is just pretty much figuring out kind of where north, south, east, and west are. All right, so there's two kinds of ways to say bearings. I'm going to use this as an example here. If I said you were out in the ocean and I wanted you to go 220 degrees, it can be a little intimidating. You know, you're floating out here in a boat and they say, okay, from where you are, go 227 degrees. From where? Well, you start by saying, imagine for a moment that you got a little compass rose right on top of that spot. Then, where is 227 degrees or whatever? Well, you start at 0 up here. If they said to go 0 degrees, that would mean go straight north. You start there and you just keep going around until you hit 227. How far am I now? 90. You ever heard of doing a 180? Okay, that would be exactly the opposite direction as you were pointed in the first place. Okay, that'd be 180. That means basically go south. 90 times 3 is 270. So going 270 is really telling you to go exactly west. And if I said go 300 degrees, let's go a little further than 270. That'd be like that direction. Okay, so I'm going to give you one. Let's say you know that you want to head that direction, but you're having a hard time explaining exactly where. And you realize, well, it's about, I don't know, it's about 10 degrees south of that line. There's two ways you could say that. You could either say, in true bearings, that's 180 plus it's not 270, so not quite that far, right? So it's 180 plus a little bit more such that it's a little less than 270. What do you think? 260. Do you get telling a person to go that direction is telling them to go at a bearing of 260? And instead of saying north, south, east, or west, you say true, 270T. If you want to write this one down as an example for yourself, I just said that's right, 260T. 270 would have been exactly west. But you've heard people give directions like, I want you to go north, northwest, or that kind of thing, right? Well, the way you officially do that, at least in this course, and I'm sure there's more than one way to do this, but at least the way we're going to do this is to say, would you agree as far as north, south, east, and west, that the direction I want you to go is generally west with a small modification, okay? So then you say it's west, and then you say how much off of west is it? Would you agree it's 10 degrees off of west? So west, and then 10 degrees south. Go west, but then modify off that about 10 degrees south of west. And that's how you'd write it. West, 10 degrees south. Or you could have just given one number, which is a lot easier, cleaner. Go 260 degrees. All right, now here's a typical challenge then. Let's say this is a 10-degree angle right there. My question is, what are the two ways to describe that direction? I'll pause for a second, see how you're doing. Okay, I hope you get that 180 would have been too far. That would have been heading straight south. So it's a little less than 180, so it's actually 170. 170 degrees true. Raise your hand if you had that one right. Okay, good. Then the other alternate way to say it is it's pretty much south, but then how much should I modify off of just south? 10 degrees, what? And you got to head in the east direction. There you go. South, 10 degrees east. That gets you to the same spot. Okay, now, how many of you got that one right? Okay, good. Now, here's how you'd actually see it in a problem. You got your boat here. And they're trying to rescue somebody who pressed their PLB button, personal locator beacon. They're kind of cool. It's like a cell phone, except a little thicker, and it doesn't use cell towers, so you can be out in the middle of the ocean and it still works. It uses satellites, okay? And it'll send your signal that I'm in distress. People do push it sometimes just to see if it will work. And the guy flies out in the helicopter to rescue you. It's a big deal. You can get charged for that. But if you're really in distress, it's awesome because like your boat's sinking, you press the button, and now somebody's going to come and get you. And it's a real peace of mind kind of thing. All right, so the beacon has gone off right there, and it'll send coordinates that it's at this latitude and that longitude. Okay, but they could then direct their boat, their rescue boat, the red dot, to go at, would you agree that looks like more than 270? It looks to me like maybe about 300. True 300. 300 true. I want you to go 300 true for 4 miles. Do you get, I actually just gave you a right triangle? Because, and this is my best advice on this helps so much, put a little plus here, compass rose, put a little compass rose there, and then draw in your vector, which goes here to there. I'm going to actually use the straight line tool to make it actually straight. There. I was off a smidge. I'll try to tweak it. Okay. Now, do you get, you really don't want to put 300 on your right triangle, but I'm going to draw in the rest of the right triangle with green here. See what I'm doing here? I'm making a right triangle where I'm going to know a bunch of the angles. Because of the fact you're using a compass rose, you have a right angle. You always will. That's really handy because in trig we need those right triangles, right? Okay, and if you really understand what 300 true means, you know that this all the way around is 300, but that doesn't really matter that much. It's what's that little angle down here, and if it's just a little more than 270, it must be 30. And if that's 30, do you get, I have now got a 30 and a 90, and therefore this has to be 60? Another way to think of it is, do you remember this thing called alternate interior angles, that angle will always be the same as that angle? So that's 30 and that's 30. That forces this to be 60. It's probably easier to just say, well, these two have to add up to 90 to make it a total of 180 in this triangle. But so there, I got a 30, 60, 90 triangle, and I know a side too. And as soon as you know a side and you know an angle, you can figure out any other side that they ask for. Like, what might they ask? They might ask, if you had gone there by going directly west and then north, how far west would you have needed to travel? In other words, that distance. And now you got a triangle where you got a side and an angle, and it's easy trig from there. So really, the problems today are not hard trig-wise. They're hard to just visualize and draw the triangle. Once you get the triangle drawing, piece of cake. All right? All right, last thing that's new is they will describe things as angle of elevation or angle of depression. Imagine for a moment we got our little person walking along on the desert floor, and they're looking up at a hot air balloon up here. I know they don't look exactly like this, but there's a hot air balloon. Okay? And I know these can get much more complicated if you're talking about the top of the balloon or the bottom of the balloon, or is it the basket, or is it the middle of the basket, or the top of the basket? Anyway, we're just going to say a spot at the bottom of the basket. Now, would you agree a person looking up and a person looking down can be described as an angle of elevation or an angle of depression. And you have to understand the difference. All right, here is normal. If you're just a normal person looking straight ahead of you, you tend to look at a horizontal, straight ahead. I know there's probably studies that say that you actually look down a little bit or whatever, but we're calling that normal. Then if he's looking up at this basket, do you get, that's called an angle of elevation. And if he has an angle of elevation of 25 degrees, then that means that angle is 25. Everybody gets the angle of elevation questions right. It's the angle of depression problems that people screw up. Here's why. Say somebody is in the basket and they're looking down. Do you get, there's actually two triangles you could draw for this. If the person in the basket is looking down, here's normal for the person in the basket. And that right there is the angle of depression. If we trust that this was really 25, then this part must be what? 65. So the angle of depression was 65. But here's where people screw up. If I just told you to draw the triangle on there between these two things, do you get a kid could correctly draw a triangle that goes like that? And so they draw the triangle, and then they go, oh, so the angle of depression is 65, and they put the 65 here. You see how that is not correct? All right. Which one's 65? Well, they can't both be 65. Okay, so what I'm trying to say is one of these is 65 and one isn't. All right. They're adding up to a total of 90. So now we're all comfortable with how the drawing looks. So what was the angle of depression? Was it 65 or was it 25? There you go. All right, so I'm going to do one more because apparently I said something wrong as I was explaining that. But the key here is don't use this as the angle of depression. It's not. This one's the angle of depression. So now we'll do guy looking down into valley. That's normal, right? All right, I want you to make a sketch, and here's the situation. You have to do all the drawing. He looks down at something on the floor of the valley below, and he looks down at an angle of depression of 40 degrees. Draw me a correct triangle for that. Nobody would mess up the angle of elevation, but a lot of people mess up the angle of depression. 40-degree angle of depression. Okay, so you got your guy here. My tendency is to draw a line like this and draw my triangle like that. And it's not wrong, but it's very dangerous because do you get, I do not have the angle of depression in my triangle right now. I'll be tempted to say it's 40 and I should put a 40 here, and that's not right because that's not the angle of depression. So what you should do to prevent yourself from doing that is to always start by taking the person whose perspective they're talking about and draw a straight line, horizontal line from them. And then you won't mess this up near as much. So then if it's an angle of depression of 40, you can say, okay, now that angle's got to be 40 because it's how far off of normal they were looking. That's an angle of depression of 40. And therefore, that's 90. And therefore, what's that got to be? What's this angle here? 50. Okay. Did I correctly draw my angle of depression of 40? Yes. Okay. See how easy it would have been to think it was there, but it wasn't? All right. So now we have to have one more side to be able to answer this question. So they'd have to give you how high the valley or how high this mountain was like this height, or they'd have to say the distance, they'd say the horizontal distance to the object was, in other words, that side. They have to give you one of those sides, otherwise you can't do it. You need a side, you need an angle. Okay? So I'll finish this off and say the thing he was looking at on the floor was a goat that it was on the bottom of the valley. Okay, and the goat, he could tell that the goat was 500 feet below him. Then this must be 500 feet. Or he's Spider-Man and he shot a web to the goat. And of course, he's got a measurement system in his web shooter, so he can tell, oh, it was 100 feet away. Then apparently that would be 100. They'll have to give you one of the sides. Okay? All right, good. That's the new stuff for today. Now, your homework for tonight is only 3 questions. Just be careful. The very first one leads off with an angle of depression question. And if you screw up that angle of depression, it's all wrong. All right, so now we have 12 minutes left, and you're going to take the quiz. Literally, the fastest anybody's taken it is 5 minutes. So I think you can finish it in, at minimum, 10 minutes. Should be no big deal. All right, that's all I got for you for today.